Hello, geometry. So I wanted to try a couple more of these, and we're going to do some of the extra practice as well, because this is critical. I don't know how else to say that. It just is. It's critical. So I already told you that lines L and M are parallel, right? And we actually have two different transversals in this one. So this one's a pretty complicated problem, but I know you guys can do it for sure. So let's take a look at, and I'm just going to cover this up right here. Let's take a look at these two angles. They both have x in them. And you'll notice this is our transversal here. So if you need to turn the page a little bit so that it's more left-right for you, that's totally fine with me. This transversal does keep going in both directions, but we don't need to care about that because both of our angles are interior. So these are both interior angles. And you'll notice that this angle is on the left or the top, and this angle is on the right or the bottom, depending on how you're looking at it. So these are alternate interior angles. Hey, that means they're congruent. So that means 5x minus 38 is going to be equal to 3x minus 4. So I can subtract 3x on both sides. I get 2x minus 38 is equal to negative 4. Be careful. Make sure you keep that negative there, that minus. Then we need to add 38 on both sides. So we get 2x is equal to 34. Divide by 2. So my x is 17. So now that I know my x, I can think about y here. And there's a couple different ways you can do it. The way I like to think about this is that I have a triangle right here. And I know we haven't talked about this very much, but all the inside angles for a triangle add to make 180, okay? You're going to learn that a lot later on, but all the inside angles for a triangle add to make 180. So that means 7y minus 20 added to 5x minus 38 added to, hey, what does this right here mean? 90, right? It's a right angle. They are supplementary altogether. Altogether, they make 180. So that means I've got my 5x is really 7y minus 20 plus 5. X is really 17. And then when I do that, I get 7y. 5 times 17 is 85. So that means I have negative 20 plus 85 minus 38 plus 90, which is 117. So I subtract 117 from both sides, and I get 7y is equal to 63. 63 divided by 7 is 9. So my y is 9. All right, I do say extra practice on this, so I'm not going to go over all of these, but I want to go over at least some of them because, as you're hopefully seeing, this is super important. L and M are parallel, so we want to identify the angle relationships. All right, I'm not going to do this one with you. You should be able to do it on your own, but I'm going to mark it a little bit for you so that you know that these are the ones that are parallel. Sorry, let me do it the same direction. There we go. All right, down here, we have some lines that are marked as parallel. We want to find the measure for each, all right? So I'm only going to write down the number, but you should be also noting their relationship. So angle 5. Angle 5 is this guy right here. Angle 5 is 82 degrees. So angle 5 and angle 1. I actually think it's going to be easier if I do angle 2 first. So angle 2 is a linear pair with angle 5. So that means I need angle 5 plus angle 2 is equal to 180. And we know angle 5 is 82, so that means I have 82 plus angle 2 is equal to 180. If I subtract 8 sides, I get angle 2 is equal to 98. So that means angle 2 is 98. Well, hey, wait a second. Angle 2 and angle 1 have a relationship. They are corresponding. That means they're going to be congruent. So this one is also 98 degrees. Angle 3, which is right over here, corresponds to angle 2. So this one is also 98 degrees. Angle 4 is down here. Angle 4 is corresponding to angle 5, so this one is 82 degrees. Another way of saying that is that it's a linear pair with angle 1. The next one is angle 6. Angle 6 is right here. It corresponds to angle 5, so they're congruent, also 82 degrees. Angle 7 is right here. Angle 7 is vertical angles with angle 4. They're congruent, so it's also 82 degrees. Angle 8 is corresponding to angle 7, or it's vertical angles with angle 5. It's congruent to angle 5. That means it is 82 degrees as well. Angle 9. Angle 9 corresponds to angle 7, or it corresponds to angle 8, or it's alternate in exterior angles with angle 5. So this is also 82 degrees. It's congruent to those. Angle 10 right here is consecutive interior angles with angle 5, so they add to make 180. That means this must be my 98 degrees. Angle 10 is also vertical angles with angle 1, so they should be congruent. They are. Angle 11. Angle 11 here is vertical angles with angle 2. It's also corresponding to angle 10, so it's going to be congruent with either of those, which means it is 98 degrees. And then angle 12 over here is corresponding to angle 11 and angle 10. It's vertical angles with angle 3, or it is a linear pair with angle 6, or it's alternate exterior with angle 2. So many relationships. In the end, all those are congruent, except for the angle 6. That one's a supplementary. So it is 98 degrees. I hope you're noticing a pattern here. Are you noticing a pattern here? Hopefully you do. All right, this one down here is a little bit more complicated, but I know we can do it. So we know that angle 12, which is right here, is 121 degrees, all right? And we know that angle 6, which is right here, is 75 degrees. We want to find the measure for each of these. All right, so let's start with angle 1. It's hard to tell, but I'm going to try and use some color, that this is the vertex right here. And if you'll notice, angle 1 and angle 6, if you fold it along this line right here, they perfectly match up. They're vertical angles. So angle 1 is congruent to angle 6, which is 75 degrees. All right, it's 75 degrees. The next one we want is, let's go with angle 2. Yeah, let's go with angle 2. So this is where it gets kind of weird because we have so many lines intersecting. And it's really hard to visualize this sometimes. So I'm just going to redraw part of this, all right? I'm going to redraw our parallel lines. And then I'm going to redraw this transversal. So this transversal is this transversal. I'm going to call it T. So there's T, this is L, this is M. So what you'll notice here is this is angle 12. And then we actually have angle 1 and angle 2 right here. Those are alternate exterior angles. They're congruent. So that means, and this is where it gets kind of weird. I did warn you first. That means angle 1 plus angle 2 has to equal angle 12. It has to. Well, we already know angle 1 was 75 degrees. And we know angle 12 is 121. So we know both of those. So we can actually find these. So I need to subtract 75 on both sides. And I get angle 2 is equal to 46. All right? So angle 2 is equal to 46. All right, angle 3. Angle 3 is next. And it is corresponding to angle 8, which we haven't figured out yet. It's alternate exterior to angle 11. So let's do angle 11 first. Well, we know angle 11 is a linear pair with angle 12. So that's 181. So angle 11 plus angle 12 is going to equal 180. Angle 12 is 121. So if I subtract 121 from both sides, man, I have terrible handwriting today. That gets 59. 59 for angle 11. There we go. Now, angle 11 and angle 3 are alternate exterior angles from each other. If you're looking at line L and M, so we're back to this kind of a diagram. This is angle 11 here. This is angle 3 there. Alternate exterior. So that means they're congruent, which means this one must also be 59 degrees. It must also be 59 degrees. So now angle 4. Well, angle 3 and angle 4 are vertical angles. So that means this one is also 59 degrees. How about angle 5 next? Angle 5 next. Well, angle 5 and angle 2 are vertical angles. So that means angle 5 is congruent to angle 2, so it's 46 degrees. Angle 7 is right here. Angle 7 is right here. And it's vertical angles with angle 12, so that's 121 degrees. Angle 8. Angle 8 is right here. It's corresponding to angle 3. It's corresponding to angle 3. So if we take a look at this little diagram again, here is 8. It corresponds to 3. So that means it is, angle 3 was 59 degrees. All right, angle 9 right here, angle 9. This one's a little trickier, okay, because we have to redraw this. So we've got our parallel lines like that, and now we're looking at this transversal, okay? Now we're looking at this transversal. And so angle 9 is right here, and angle 1's up there. Those are both in corresponding positions, so angle 1 and angle 9 are congruent, so that means angle 9 is 75 degrees. All right, our next one is angle 10 right here, so angle 10's there. And it's going to correspond, actually, let's do this one. Those are consecutive interior. So that means angle 6 plus angle 10 is going to equal 180. Angle 6 we know is 75 degrees. So if I subtract 75 on both sides, we get angle 10 is 105. All right, and then we need angle 13. Angle 13 is vertical angles with 10, so they're congruent, so that's 105 degrees as well. And we are down to our very last one, which is angle 14. Angle 14 is vertical angles to angle 9. Angle 9 we said was 75 degrees, so angle 14 is congruent, and it's also 75 degrees. I know, those ones are complicated. They are. I really want you to challenge yourself with those. All right, on this side here, we've got another one that's complicated. I want you to practice it. All right, practice it on your own, both of these. The answer key is already posted to the drop for this week, okay? And then down here, it didn't actually say it, but all of these assume that L and M are parallel. I don't know why that didn't print on all of these, but it didn't. And then you are solving for X and for Y, okay? I hope this helps a lot. Please email me if you have any questions.